Good morning, friends. How are you all? I am so long. I'll show you the drawing of a traction substation which is drawn in electrical AutoCAD. Electrical AutoCAD. Due to this, the picture is clear here, and I am interested or eager to describe you the traction substation. You know, for any movement, anything, any operation, we need power. And in electrical system also we need power, electrical power. And the source is generating station. Generating station. Though generation is in a comparatively low voltage, means around 6.6 kV, 11 kV, 13 kV. But for transmitting power due to low voltage, the conductors will be more thicker due to high current, because our traction load is drawing huge current, and if you keep the voltage low, then the transmission line conductor will be having more cross section. So to solve this purpose, we are raising the voltage. Nowadays we have raised the voltage from 66 kV to near about 735 kV. Think 735 kV kilovolt. That means 7,35,000 volt. But it is somewhat rare now. Usually we are using 132 kV or 220 kV and somewhere 400 kV. These three voltages, 132 kV, 220 kV or 400 kV, is somewhat popular for transmission purpose. But in our overhead traction system, the conventional system using 25 kV, and the new system, that is 2 into 25 kV, which means 50 kV. So after transmitting the power through transmission line with high voltage, we are stepping down it to 25 kV or 2 into 25 kV. 2 into 25 kV. Or generation generally in three phase, red, yellow, blue. And with the use of tower, transmission tower, we are receiving in the traction substation. But you know, this relay is an essential commodity, so you it needs uninterrupted power supply or minimum interruption, because uninterrupted fully cannot be achieved till date. So what we have done, we used two source, two transmission system has been taken with the tower. Suppose one is from Orissa State Electricity Board and another is West Bengal State Electricity Board. So if one fails, the other will continue the power supply in the traction substation. Another system we also know, that is feed extension in the 25 kV side. Suppose both the power supply fail in the traction substation, then in the 25 kV or 2 into 25 kV we can extend the feed from the other traction substation. So many options to keep the power supply uninterrupted. Then generally in conventional system we are using single phase transformer. But this single phase transformer is using two phases. Here in the picture I have shown red and yellow phase. Why phase? Because phase to phase voltage is more. If I use phase to neutral, then the voltage will be reduced. So we are using two phases in the single phase transformer. Here it is red and yellow. Then every electrical system, main thing is its earthing and its isolation and charging system. Isolation and charging system. So for isolation, first we have to prepare the earthing system. Earthing mesh is arranged just 600 millimeter below the ground level, and all system earthing and equipment earthing is connected with that grid. Even the traction rail is connected with the grid in front of the traction substation. So first is the earthing system and its isolation or energizing system. And another thing is protection. Protection is also very much important. If any fault, what type of fault? It may be dead earth fault, it may be an earth fault from distance place from the TSS, which is not sufficient to trip the overcurrent relay. The current is so low. At that time also this distance protection relay will protect, and the relay will feed the trip circuit of the circuit breaker, and circuit breaker will trip. Another is delta I. Somewhere the resistive path is too high. Suppose the conductor fallen on the ballast of the railway track, so it is not a dead earth fault immediately. So a changes will occur suddenly, the changes of current. So that will be sensed by delta I relay, and your CB will trip. And other protection is over current relay. If number of train runs which is beyond the capacity of the traction substation current capability, then it will trip, or the traction transformer is overloaded, then also the relay will trip the circuit breaker. Now another relay we are using, that is wrong phase coupling. Wrong phase coupling. What is wrong phase coupling? We are distributing the phases in adjacent TSS chronologically. Suppose here we have used red and yellow. Next TSS we will use yellow and blue. Next TSS we will use blue and red. So that all the three phases will be loaded. And here we have connected the yellow phase to the overhead system. In the next TSS, it may be possible that the red phase is connected to the overhead. So in OHE, there is phase difference between two TSS, and to avoid the short circuit, we are providing neutral section in the mid of the two TSS. And in case of power failure of one TSS, we can close the bridging interrupter across the neutral section so that feed can be extended from one TSS to the TSS where power supply failed. This is called feed extension. We cannot interrupt the power supply for a longer period, not longer, even 1 to 2 minutes. So this feed extension possibility is there, facility is there in the overhead system. Now what we have done, we are using two types of isolators. One is double pole isolator for two phase, and single pole isolator in the single phase. And Then circuit breaker. Circuit breaker is also two types: double pole isolator, double pole circuit breaker, and single pole circuit breaker. But some are triple pole isolator is also used. Triple pole circuit breaker is also used where the design of the traction substation has changed. Suppose in 20 to 25 kV, in 20 to 25 kV we are using all the three phases for Scott connection and open delta or V connection. There they will use triple pole isolator and triple pole circuit breaker, and with this double pole and single pole. So this is the system of isolation. This is the system of isolation. For energizing the transformer, first you must close the no load switch, means isolator switch. Isolator switches closing in air. So if you close it in live condition, then a spark over will take place and the isolator will be melted. Why? Because when you are closing, when the air gap step by step is reducing, the air will be ionized and a spark over will take place and the isolator will be melted. So first you close the isolator when the circuit is not continuous, means open circuit. At that time only you can close the no load switch. Then you close the double pole circuit breaker to charge the traction transformer. When the traction transformer is charged, you close the single pole isolator of the transformer after the CT. Then it is no load switch. First you have to close it. Okay. Next what you have to do? You have to close the single pole circuit breaker. Then the power will be fed to the common bus. That means coupling the two buses. A bus coupler SP isolator is there. Normally it is in closed condition because it is in open. If it is in air, closing in air, so normally it will be in closed condition before the charging the transformer or this bus. Then we have provided two auxiliary transformer to feed the 230 volt supply. One is 100 kVA and one is 10 kVA. 100 kVA is for traction transformer oil filtration. 100 kV transformer is for traction power oil filtration. It is the transformer side. Next I will discuss about the feeder side. In the feeder side, again single pole isolator. For two single pole isolator, then potential transformer, then current transformer, then single pole circuit breaker, then again an isolator, then the bus coupling arrangement with an bus coupling interrupter, because it will be closed, it can be closed in energized condition as well as in no load condition, even in short circuit condition. This is the capability of an interrupter. You can close it on no load to full load to faulty condition, but if you close it during faulty condition, the circuit breaker will trip and the section will be protected. We are having neutral section just in front of the TSS. Then for each up and down line we have provided 4 interrupters, just two sides of the neutral section. One is for up line and one is for down line. So CTPT, this is for protection system and metering system. Okay friends, in the next slide I'll show which portion is movable. You see it. In this system, the closing operation has been shown in the red color. That means it can be closed. This isolator can be closed. The circuit breaker can be closed. This interrupter can be closed. This breaker for main or interrupter can be closed. The video is becoming longer. Okay friends, thank you, be happy.